Alright, so looking at the first do now problem, we've got a integer subtraction problem. So looking at this, we need to go ahead and change this to an addition by making it an add the opposite. So we have negative 32, add the opposite, which is 15. Here we think about quick arrow diagram. We have 32 in the negative and 15 in the positive, which is still going to keep us on the negative side of 0. Opposite direction, so we have 32 minus 15 is going to give me 17, negative 17. Moving on to the next one, we have another subtraction, so we'll change this one to an add the opposite as well. Here we're going to end up with a standard addition, arrow, arrow in the positive direction. So we're definitely going to end up positive. We're going to add the values together. We're going to get answer choice C. Alright, let's move on and look at our aim for today. Kipsters will be able to find the distance between and change between integers. So notice the structure here that I have talked about the distance and change as two separate things, because those two things mean very different things. When we're talking about distance, remember we've had this discussion before, we're talking about distance, we're talking about how far apart something is, which doesn't have a direction. So when we talk about it, we don't ever talk about distance as being positive or negative. Change, on the other hand, does have direction. It can be left, right, up, down, and that's why we usually describe change as either being positive or negative. So remember that difference today between those two vocabulary terms. Distance does not have a direction, and change does. Okay, so let's look at our first amount of work here. We have person A on one side and person B on the other side. They are both going to be calculating the distances between 2 points. And so I actually want you to go ahead and figure this out on your own. I'll do the first example with person A for you, and then I want you to do all of the rest of the examples on your own. So I'm going to start here with person A. We're looking at point -4 and point +5, and I can count that between them the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9. So for this, I see that my distance between the 2 points is 9. A couple things to notice here. We are using the word distance, so direction doesn't really matter. We're also looking, notice how when I draw my kind of distance bar here that I don't put arrows on it, indicating that there isn't really a direction. So a couple things to keep in mind as you're working through this. Please go ahead and calculate the distance between each of these points, person A and person B. You'll need to pause the video so you can get that done. Okay, after doing the work here, you should recognize that we have all of this work here. What is the distance between -4 and 5? What's the distance between 5 and -4? They're both 9. Now again, notice that there's no directions on here because we're talking about distance. It doesn't matter which direction it's going. Were person A's and person B's answers the same for the second and third problem as well? Okay, looking through that, obviously we can see here that indeed, yes, 2 and 2, 8 and 8, these are going to be the same answer. So why did we get the same answer? All the problems are slightly different. Just looking at the example from the first one, -4 and 5 and 5 and -4. Why would we get all three problems end up having the same answer? Go ahead and ponder that and write your answer down. So hopefully when we're thinking about this, we're thinking about the distance is always going to be the same because it's the same 2 points. And direction didn't matter. Think about it this way. If you're walking from your house to school, is the distance going to change whether you're walking from your house to school or from your school to house? The answer is no, that the direction isn't going to matter which direction you're going. What only matters is how far away it is. Direction doesn't matter. We're only talking about distance. Now, thinking about some of the definitions we've already used so far this unit and some of the definitions you've used last year, what vocabulary term is used to represent the distance between a number and 0 on a number line? Hopefully you've come up with absolute value. We can see an example down here. If the distance between 5 and 0 can be calculated by saying it's the absolute value of 5 minus 0, or the absolute value of 5, can we calculate the distance between -4 and 5 using the absolute value? Take a minute to see if this works. So again, we're seeing that they're subtracting the two values and then finding the absolute value of that. So calculate that for -4 and 5. So I'm going to rewrite this as an addition. Add the opposite. It's going to tell me I'm looking for the absolute value of -9, which is 9. So this does look like it's going to work to help us find the distance. So when we find the distance, remember those absolute value symbols, really all they're telling us is that, hey, once you get to this point, order does not matter. Once you get to this point, direction does not matter. Will this work out for the other two exercises? Well, let's go ahead and test it out. We've got -5 and -3. -5 minus -3. And 7 and -7 minus -1. Alright, so looking at this, I'm going to change this to an addition. Add the opposite. And that's going to give me the absolute value of -2, which is equal to 2. And that's sure enough the answer that we got. Same thing over here. I'm going to change this to add the opposite. Absolute value of 8 is 8. So no matter what way we do it, again, we're going to see that this idea, this formula, works to help us find the distance, or the absolute distance, between two values. Alright, go ahead and use a number line to answer the following questions. So in each of these, we're looking for the distance between 2 points. Go ahead and use the number line to do that. Go ahead and pause the video and make that happen. Alright, so once we've done this, the distance between 0 and -8, so we have 0 and -8. Looking for this distance, we should be able to count over 1, 2, 3, 4, 5, 6, 7, 8. Over here, what is the distance between 2 and -1/2? Okay, so this one, -2 is here. -1.5 would be between these two. So actually I can see the distance between these two is only half. And the distance between -6 and -10 counting over, 1, 2, 3, 4, should get that our distance is 4. Alright, so that's pretty simple, just a different way to use the number line. The number line we can use the counting method just like we used counting method early on to figure out integer additions. Alright, so find the distance between -3 and 2. So again, -3 and 2, use the number line. We count 1, 2, 3, 4, 5. Tells me that the distance between them is 5. Now, using the formula, we could say that we subtract then find absolute value. That's the formula that we saw on the other side. And we're just going to write that down, just really generally down here, to find the distance between two rational numbers. Again, distance, distance, distance. Not anything about change, distance. We need to subtract and then find the absolute value. And that's just what this formula has us set up to do. The same formula that we used over here. Alright, let's flip on over to our partner work time. We've actually got a few more problems that I want to walk through. Okay, so looking at this, we just have a quick reminder up here at the top that distance is positive, or distance has no direction. Change, on the other hand, whether it be elevation or temperature or whatever, that has a direction. We're either changing up, or we're changing down, or increasing, or decreasing. Change definitely has a direction. And that's just a vocabulary piece that we need to come up with. So this first example says a hiker starts hiking at the beginning of the trail at a point that is 200 feet below sea level. So just thinking about this, we're going to draw a quick vertical diagram. We'd have 0 here, and he's down here at -200. That's kind of where he's starting. He hikes to a location on the trail that is 580 feet above sea level and stops for lunch. What is the vertical distance? So again, we're talking about distance here. We're just looking for how far it is between these two things. I can use my formula, -200 minus 580, take the absolute value. That's going to give me -200 plus -580, which would be equal to the absolute value of -780, which is 780. We could think about this on the number line in terms of it would take me 200 to get to 0, and then another 580, so that's why we combine the values. But we have a distance, so we're not really worried about direction. How should we interpret 780 feet in the context of this problem? And that's just pretty simple. Using that same language, the distance between the 2 points is 780. Make sure we get our units in there since we're talking about the world or real world problem. 780 feet. After lunch, the hiker decides to go back down the trail. So, quickly sketching, he was 580, and he's going back down to the bottom where he started, -200. What is the vertical distance? So again, we're looking at the distance between the 2 points. This is going to be 580 minus -200. Add the opposite, 580 plus 200. is absolute value of 780, which is 780. So again, we see the distance hasn't changed regardless of what direction he's walking. And that's that concept that we're talking about. Distance has no direction. However, this asks us what the change in elevation is. Okay, so for this particular scenario, now we're going from 580, that's our start value, down to negative 200. So when we're talking about change, we're always talking about end minus beginning. Just as a quick example to the side, if we start at 2 and go to 7, we would calculate that as 7 minus 2. The change is 5. Notice that's positive because we went forward. Okay, that's one way to always quickly check. Make sure that you're quickly identifying as an increase or decrease appropriately. If we get a negative answer, that would suggest that we decreased. So just thinking about this scenario here, we went from a 580 to negative 200. Should our change be an increase or a positive or a decrease, a negative? Hopefully you've identified for yourself that our answer definitely should be a negative because we've decreased the value here. So if we want end minus beginning, that's going to be negative 200 minus 580. Change that to addition of the opposite. So we're going to get, oops, let me just go ahead and erase here. Negative 200 minus 580 is negative 200 plus negative 580, which would give us negative 780. And that's exactly what we were looking for. We were looking for a change of negative because we went down. All right, so again, what this problem particularly shows is that distance is going to be always look like a positive value because it has no direction, and change can be positive or can be negative depending on which direction you're going. That's the key takeaway from this particular problem. Alright, over here on the right hand side, just want you to walk through these couple of problems, making you think conceptually about some of these changes or distances. Please go ahead and finish this. Pause the video now and come back to check it when you're done. Alright, so we have lots of possibilities here. You can come up with all kinds of possibilities. I'm just going to quickly sketch a number line to help me think through this. It wants me to have one positive number and one negative number. So just quickly sketching a number line, maybe I'm going to go with negative 6. And so on the other side, if I had negative 6, my distance to 0 would be 6. And so that means I would need 6.5 more distance over here. So that's going to need to put me at negative 6.5. So 6 and 6.5. Or maybe I start at 4. That tells me my distance between 4 and 0 is going to be 4, which means I need another 8.5 on the positive side. So negative 4 and positive 8.5. Alright, so again, talking about distance, really no direction there. Find the distance between negative 7 and negative 4. It says use the formula and use a number line to support your answer. So using the formula, negative 7 minus 4. Okay, so direction didn't matter here. I'm going to change this to addition of the opposite. So this is going to be absolute value of negative 7 plus negative 4, which is the absolute value of negative 11, which is 11. Alright, so looking at this, clearly I have made a mistake somewhere. because as we look at this on the number line, the distance between -7 and -4 is just 3 units. So let's go back and find my mistake, the distance between -7 and -4. I come back and I look at it, my mistake happens right up here at top. This should have been a -4. So when I added the opposite, it should have been plus a +4. So we have opposite signs here going in opposite directions. That's going to give me the absolute value of -3, which is 3. Alright, quick fix. The change in temperature, change. Alright, end minus beginning. From -18 to +15. So thinking about this, we're going from -18 up to +15. So I should be thinking ahead of time, is this going to be a positive value or a negative value? Answer is that it should definitely be a positive value because we're increasing. If I'm using my formula, end minus beginning, 15 minus -18, change that to adding the opposite. That's going to give me a positive 33. Would our answer be different if we were dropping from 15 down to -18? So yes, that's going to make it different. It's not going to change the distance between the two things, but it will change the direction. And since we were talking about change in temperature, direction does matter. Our answer would be -33. Alright, Beryl is the first person to finish a 5K race and is standing 15 feet beyond the finish line. Jeremy is currently trying to finish the race. He's 14 feet before they reach the finish line. What is the minimum possible distance between them? Alright, so looking at this, just thinking about them on a race number line. One of them is on 14 feet on the other side, then it's 15 feet on the other side. We could talk about the 14 being the negative. And so we can think about this just in terms of conceptually. It's 14 to the finish line, another 15 to Beryl. So that would be 29. Or we can think about it using the formula, -14 minus 15 absolute value. Change this to an addition. Absolute value of -29 is 29. And last one, change in elevation from 140 feet to 40 feet below. So thinking about this quickly on a number line. At -40, 140. So we're going from 140 down to -40, so our answer should be negative. And looking at this, we could change the absolute, or no, it's not absolute value because we're looking for change. So -40 minus 140. Change that to adding the opposite, -40 plus -140 is going to give me -180 feet. Alright, go ahead and move on to your independent work.